We're now going to learn how to sketch the derivatives. So in other words, we get given a curve and they'll ask us to sketch its derivative curve. I'll start off by telling you that at school, this was one topic that, despite how good my teacher actually was, this was the one area that I really struggled with because I didn't have a system to work from. And so it would take me a long time to transfer it over and work out exactly how to sketch the derivative. But in the end, I'd get only a couple marks worth, and it took me 10 minutes. I really hoped I wouldn't see these questions, and if there were, I'd leave them to last. They just weren't worth it. But it's just because there wasn't a system, and that's what I've developed in order to do these questions effectively. So let's start off with that. It's a little cheat sheet that I actually drew up in order to help us. The way that it works is we've got our f of x, and they want us to draw our f dash x curve. So we need to, from the f of x, we need to sketch the f dash x. And here's how it goes. The gradient of the f of x becomes the value of the f dash x. So if the gradient of the f of x is positive, the value of the f dash x will be positive. Wherever the f of x has stationary points, they become roots of the f dash x. And wherever the f of x has points of inflection, they become stationary points on the f dash x. Okay, that is a little bit confusing for now, and it's also hard to remember. That's the hardest thing I found, is it's quite difficult to remember exactly what becomes what and when and how. That'll all make sense, but that is our little cheat box over there. And I'm going to show us a good way to go about remembering that. Okay, there is our cheat sheet. Now I'm going to make it easier for us in terms of shorthanding it. So I'm going to abbreviate all of those. Gradient becomes grad, value becomes val. It's just shorthand because you need to be able to draw up this box for every one of these questions. Draw it up first, it'll make life much easier for you. So that's the box as it is that you'd want to draw out. Nice and shorthand. But how do we remember this? How do we remember what becomes what and where? Well, the technique that I'm about to show you to remember it is actually so useful, not just for maths, but actually across the board for all subjects. And why I developed it, well, I studied a little bit of psychology at university and learned a little bit about memory and how we absorb things and how do we remember certain things better than others. And one of the key facts that I took out of it, which is something, I guess when you think about it, it isn't that crazy, but the weirder something is, or the more out of the ordinary something is when you see it, the more likely you are to remember it. You don't remember the mundane, average stuff. But if something's really crazy and out of the ordinary, that's Sing Singing and you remember it. So for me, I like to make up lots of stupid stories. And that's what we're going to do here. Make up a stupid story. The more weird and wacky you can make it, the more likely you are to actually go about remembering it. So that's going to be our key. Now, onto that. Here is our story. So the story is about a grad party and value. So grad was for graduation, and val, which was for value, I've made for valium. So that's what the story is. It's a story of graduation and valium. Okay, ready? Sparked your interest. Now, this is where it gets interesting. I'm going to separate that because that was just our title of the story. It's about graduation and valium. Now here's what happened. These are the critical points of the story. And I use the word critical points because it kind of it's a good pun. It defines the actual critical points in the graph, but it's also the key points of the story that I want you to remember. So here's the story. We having our grad party. These dodgy guys bring Valium to it. These dodgy guys I want to call stupid people. STPs. So the stupid people. These stupid people who are on Valium, they start rooting each other. Now, I don't intend to get explicit or anything. It's just a nice way to remember it. You've got these stupid people, all high or low on Valium, whatever you want to call it, and they go around rooting each other. So stupid people become roots. Then the police catch wind of this situation. They hear about this grad party with Valium. They rock up and they arrest the stupid people. So those are the key things. There were stupid people at the party, started rooting. Police arrived and locked up the stupid people. And there's our story. Those are the critical points, and it's the story of the grad and Valium. So hopefully that made sense, and hopefully you're thinking, whoa, that's stupid, because yes, it is. And that's the intention. The dumber, the better. Now let's see if you remember that. Let's go through it again. F of x to f dash x. Remember, stupid stories are more memorable. So, here's our stupid story. I want you to tell me the story. Say this out loud. Make sure you're following it as we go. So, in the story, it was a story about our grad and Valium. So, gradient becomes value. Grad becomes Valium. Alright, now, what were the critical points in the story? What were the two main critical points to remember? Well, we had these stupid people, and they were going around rooting. So the stupid people root. Perfect. Alright, what was the other key point? What was the other critical point to take out of it? Well, the police caught wind of it, they rocked up, and the police arrested the stupid people. And there's your cheat box. Grad, val, stationary points, root, point of inflection, stationary points. That's what I want you to draw up every single time. And the way to remember it is through that stupid story. Now, if that one didn't make sense for you, or you don't like the story, or you can make up a better one, then please do. I've actually changed the story loads of times over the years. Some people will relate to certain stories more. Some will relate to stories that they've made up. So go for it if you feel that. If not, and you follow the story of the grad party and the Valium, great. Alright, but that's what we need. That's how I go about remembering it. So we need that box. Here's an example. We get given a curve like that, which is our f of x, and they ask us to sketch the f dash x curve. So what did I say is the important thing that you have to do for every one of these questions? Once you do that, these questions are easy. And that is draw up your little cheat sheet. So there's our little box. Write it out every single time. We've got our story and we've got our critical points. Okay? Here's the process that I want you to follow to make that easy. First things first, I want you to do dotted lines and labels on the critical points. So let's start off with the critical points about the story. Think about a newspaper or an article. You'll often, in order to really understand what's going on, you'll often read not just the title, because that won't do the trick. It's normally that first line or that first sentence, the couple critical points that will give you an indication of what's going on. So let's first see what's going on, and then in part 2 we'll finish telling the story. So we'll use the grad and the val. So does that make sense? We start with the critical points, and we do a dotted lines and labels on those, which you'll see, and we then finish telling the story. Okay, so first things first, we do dotted lines and labels on the critical points. Our critical points in this case are, we are looking, in our f of x curve, we are looking for the stationary points and the points of inflection. Those are our critical points, and they will become roots and stationary points respectively. So we're looking for stationary points and points of inflection. And we can see we've got a stationary point at 3. So what we do is we draw a dotted line down. And you want to draw your f dash x curve right underneath it, because each of these critical points will relate to one another. So when we draw our dotted line, we draw it right down through the 3 on both graphs. So stationary points, remember I said dotted lines and then label it. We labeled stationary points, and that will become, look at our cheat box, that will become a root. And roots we know go through the x-axis, so we'll put a little dot there. We know that our curve is going to go through there, because that's what a root is. Now we look, are there any points of inflection? Well, you look at that little parabola on the f of x and you'll see there's no points of inflection. It doesn't change concavity, it's concaving down the whole time. Which means there'll be no stationary points on the f dash x curve, based on our cheat sheet. Okay, so we're done with the critical points. There's just the one in this case. Now what we do is we do the second step, which is we finish telling the story. What we do is we look at the gradient of the f of x, and that gradient becomes the value of the f dash x. Value being above or below the x-axis. So a positive value is above, a negative value is below. And that's how we work. We take the gradient from the f of x, it becomes the value of the f dash x. So we look at that curve and we see up until that critical point, we've got a positive gradient. Positive gradient translates to a positive value. So we're going to be up above the x-axis in the f dash x curve, so where that plus is. And on the other side, the negative gradient will translate to a negative value. So gradient becomes value. So what we're going to do now, we finished telling the story. We know it's going to be in the region where that plus is. It's going to go through the root at 3, and it's going to finish in the region where the minus is. So it becomes that straight line over there. Now that makes sense as well, because if you look at that first curve, it's just an upside down parabola. Now if you differentiate a parabola, which is x squared, you bring down the power minus 1 from the power, you land up getting 2x, which is a line. So a parabola will become a line. A cubic will become a parabola. A power to the 4 will become a cubic. Because when you differentiate, you're just reducing it by 1 power. So that makes sense algebraically, but now graphically as well. So hopefully you followed that. By just working off the cheat sheet, you can actually see what becomes what and work accordingly. Let's do a slightly harder example. Write out your cheat box there. You've got your story and your critical points, and we're going to follow that same process. Now it's a slightly harder one though. So first things first, we look for our critical points. So we're going to look through and we're going to try to find our stationary points and our points of inflection, because they'll become the roots and the stationary points of the derivative curve respectively. So stationary points, well, we've got one at 1, we can see that. So we draw a dotted line down through the 1 of both curves, and stationary points become roots. So we can put a dot at the root there on the x-axis, because that's what a root means. Any other stationary points? You should have picked the one at 3. Beautiful. So with a stationary point, you label it, you draw a dotted line down, and you label on the f dash x, because that's going to become a root. Great. Any other stationary points? No. Any points of inflection? That's another critical point. Well, you should be able to see the one because there's a change in concavity. Critical points are done. A max Beautiful. to a min, or a min to a max.
Now we got
It
to
has
finish
change
telling the story.
in concavity at some point. So, and you should be able to see it changes at the 2. So that there will be a POI at 2. Dotted line down. What do POIs come? Look at our cheat sheet. They become stationary points. Now, what will that stationary point be? Will it be a max? Will it be a min? Well, we don't actually know which it's going to be. That's why we have to finish telling the story. So our critical points are done, and that's what we move on to, our storytelling, the gradient and the value. So we look at our gradient of the f of x curve, and we see that will become the value of the f dash x curve. So let's start off and we'll move between each critical point. So we'll start from the 0 to the first critical point to the 1 there. And we see during that period it is a positive gradient throughout, which means it's a positive value throughout on the f dash x. Between 1 and 3 we've got negative gradient. And with a negative gradient we have a negative value in the derivative. Then from 3 onwards we've got a positive gradient again. A positive gradient means a positive value in the derivative. Are you getting that pattern now? So we can see the curve needs to go through those 2 roots that we've marked at 1 and 3. It needs to be up where that plus is, down below the curve where that minus is, and up again through where that plus is. So it should draw itself, and we know there's a stationary point, either a max or a min at 2. Well, now we can clearly see it's going to be a min down there. So when we draw it, it's going to look a little something like that. Perfect. And that is how you sketch the derivative. Once you do a few of these and you get the habit down of using your cheat sheet and just following that process, they become pretty easy. Let's try something slightly different. And I've seen these asked before. They might give you a derivative curve and ask you to sketch its original. So it's the reverse of what we've just done. So there you can see they've given us the f dash x, and they're asking us for the f of x. So draw out your cheat sheet, draw out your little box there. But now what we're doing is we're actually going to be working backwards, going from the f dash x to the f of x. So we work in backwards. So process is still the same. Start with the critical points, then finish by telling the story. In this case, our critical points are the roots and the stationary points, because they'll become the stationary points and the points of inflection respectively. So we are looking in the f dash x for roots and stationary points. Well, we can see a root there at 1, dotted line that, and that becomes a stationary point. We're not sure what type yet, but we'll see when we finish telling the story. Any others? Well, yeah, there's a root there at 3. Draw it up, that's going to become a stationary point. We'll find out what one later. Any others? Well, no more roots, but any other of the critical points. In other words, what are we looking for? We're looking for stationary points. Yeah, well, there's the obvious one at 2. So we dotted line it up, label it, and what do stationary points become when we're working backwards? They become points of inflection. So we label that there. So now we know our critical points. We've just got to finish telling the story and connect that and make it make sense. So this is slightly tricky because remember we work in backwards. But now we are working, when we're telling the story, we are looking at the value and that will become the gradient. So before it was the gradient to the value, now it's the value becomes the gradient. And that's why it's so important to draw that little cheat box out so you can see it visually and work forwards or backwards depending on the question, but you can see it visually. So we're looking for the value. Well, down here, that's negative value below the x-axis. So negative value up until that 1 will become negative gradient. Doesn't matter where you started as long as it's a negative sloped line. Then between 1 and 3 you can see all of that is positive. Positive value because it's above the x-axis. What will that be? Well, positive value will become positive gradient. So it should just go up. From 3 onwards we've got negative value again. Negative value will become negative gradient. Hope that's making sense, because it's almost like I'm repeating myself because I'm just following a system. So you can see that's almost drawn itself out. You can see the stationary point at 1 is clearly going to be a min. The stationary point at 3 is clearly going to be a max. It's going to inflect on that at 2 where we've said there will be a POI. So we can pretty much draw that out now. We can see exactly how it's going to be done. Now with all of these sketch the derivative questions, it doesn't have to be exact. They're not going to be marking you in terms of how steep your curve is or shallow, because that's variable. That can change. What's important is that you've got your critical points and that you're hitting those. For example, a curve like this. Notice how it's got a stationary point at 1, point of inflection at 2, stationary point at 3. Or like this. Same thing. All of these are absolutely correct, but they've all got the same key features. They've got the same critical points. Look there. All have stationary points at 1. Here, all have points of inflection at 2. All have stationary points at 3. So it doesn't really matter how you draw it as long as you are hitting your critical points. If you want to continue the analogy that you were using, it doesn't really matter how you tell the story. Everyone will tell the story a little differently, but as long as your critical points are correct. Different newspapers are covering a story. Everyone will write it differently, but the critical points still stay the same throughout. It's just they will then tell the story differently.